Hiya, today we're going to work through 2016 paper 1. This is part 1, so we'll do about the first half of the exam paper, then you'll try the following 5 or 6 questions, and remember, come back because there'll be part 2, which will complete the rest of paper 1. So it's all non-calculator work today. Number 1, a vector question. Find the resultant vector of a half p plus q. So basically we're going to half vector p, okay? So a half of vector p is a half of that one, and then we have to add on this one. Now, you don't have to set it out like this as long as you get the right answer. So a half of vector p is basically half the components, half the numbers that are in vector p. So half of it would be 2, negative 3. Okay, that's me half the 4 and the negative 6. And now what I want to do is add on q. Top number, add the top number. 2 add negative 5. Remember, that's 2 take away 5. So the top number will be a negative 3. And on the bottom, we've got negative 3 add negative 1. Negative 3 add negative 1 is negative 3 take away 1. So the bottom component is negative 4. Okay. Remember, what you should be doing is stopping the video throughout, take any notes that you need to, okay? Right, number 2, it's a fraction question, evaluate and give your answer in its simplest form, okay? Right, just to check, the 3/4 bit at the front of the bracket, that's multiplying with the bit inside the bracket. Now, if you would have done this question slightly different from the way that I'm showing you, pause the video at the end, do it your own way and just come back and double check the answer, okay? What I would be doing is I would be working out the bit that's inside the bracket first, okay? So I'm going to work out this part and then I'm going to deal with the 3/4 at the end. Right, adding fractions. We can only add fractions if we've got a common denominator. 3 and 7, 21. 3 and 7 both go into 21. It's a common number that they both go into. Right, 3 turned into 21 by multiplying by 7. So this side is going to get multiplied by 7. 7 ones, 7 at the top. This side, okay, on the right-hand side, the 7 is now a 21. How did we manage that? Well, we must have multiplied it by 3, times the 2 by 3 as well. Okay, 6. So really what we get when we add a third, add 2 sevenths, is 13 over 21. Okay, so that's me combined the bit in the bracket. Now I'm going to have to deal with the 3/4 bit that was at the front. The 3/4 bit at the front, just to double check, the 3/4 is stuck to the 13 over 21. That's a multiplication. We're multiplying them together. Okay, that's what that is doing, multiplying it together. When you multiply fractions, remember the easiest way is, some people multiply straight across the top, some people multiply straight across the bottom, that's fine. 3 times 13 is 39. You have a wee bit of simplifying to do. However, I like to simplify it a wee bit in advance. Top and bottom, divide top and bottom by 3. So I'll make this 21 a 7. And now it just means the numbers are a wee bit easier to deal with. 1 times 13 at the top, and 4 sevens, 28 at the bottom. Okay? And again, if you'd have done it a wee bit different, pause the video and just double check you get the right answer. Okay? Right, next one. Number 3. So let's see, the diagram shows a sector. The radius is 20, the angle is 45. What's the area of the sector? Right, this is a non-calculator, remember? So we have to use 3.14. So put your calculator away, please. Right, the area of the sector. Now, you must know this area of a sector formula. It's not a formula that's given on the formula list. The area of a sector formula is the angle over 360 times by area of a sector, area of a circle, pi r squared. I'm just going to score that wee number 3 out there, okay? That wee 3 was 3 marks. Okay, so it's the angle over 360 times by pi r squared. The angle is 45, so it's 45 over 360. Pi is not the pi button, remember, we're using 3.14 as the pi, and the radius squared, 20 squared. Now, don't be put off by the fact that this is a non-calculator question. They've picked numbers that should be easy to deal with, okay? I know that looks really complicated. 45 over 360, whenever this comes up in an exam, right, 45 over 360, I'm going to put it up here. that can be simplified. Okay, basically what fraction of a circle is that? It's not a quarter of a circle, it's not half of a circle. I'm going to simplify top and bottom, make it a wee bit easier. What can I divide 45 and 360 by to make the numbers easier to manage? I'm going to divide top and bottom. You've probably found a quicker number to divide by, but I'm going to just do it wee bit by bit. I can divide the top and bottom, and actually divide by 45, right? Okay, how many 45s are in 360? Well, I know two 45s make 90 and four 90s make 360. Alright, and again, see if you're, in fact, no, I won't do it that way. Let me rub that out because I don't think many of you would have been okay with that sum. Right, I'll make it a wee bit easier. Right, 45 and 360, divide them both by what? I'll divide them both by 9, okay? At the top, how many 9s make 45? 5. At the bottom, how many 9s make 360? Well, I know that 4 9s make 36, so it's actually 40. Okay, but that 5 over 40 goes down again. Divide top and bottom by 5. It's 1 over 8. Basically, 45 degrees is an eighth of a circle. You might have noticed that straight at the beginning. You might have not. If you didn't know it was an eighth of a circle, you'd have had to have done that simplifying part here, which I've done. Okay. However, remember, 45 degrees is just half of a 90 degree. So 90 degrees is a quarter of a circle. 45, you might have noticed, is just half of a quarter of a circle, so it's an eighth. Right, so what we've actually got here is an eighth times 3.14 times, what's 20 squared? 20 times 20, 2 times 2, 400. Right, we need to tidy that up a wee bit. It's a bit complicated the way it stands. Let's see. You don't need to divide the 3.14 by 8. You can if you want. I actually find it's easier to divide 400 by 8. Okay, 400 divided by 8. 40 divided by 8 is 5, so 400 divided by 8 is 50. So basically this is 3.14 times 50. And again, if you wouldn't have done it the same way as me, pause the video, work it out in your own way. 3.14 times 5. I'm going to times by 5, then I'll put a 0 at the end or multiply by 10. Let's see, 15.7. Okay, but it's 3.14 times 50, so not 15.7, it's 157. And it's squared centimetres for the area. Okay. Right. Number 4. This one here, we have, looks like a simultaneous equation question. We've done one like this in the last paper. Pretty much comes up every year. Remember, this is non-calculator, right? 2 cloaks and 3 dresses, and the total material was 9.6. Write an equation. So I'm going to let C be cloaks. So 2 cloaks, add on 3 dresses, equals 9.6. Okay? The following day, Charlie made 3 cloaks. Make a new equation. 3 cloaks and 4 dresses, and this time it was 13.3. Okay, so these are our 2 equations. Remember, look at the number of marks. It tells you that's straightforward. Okay, we're not expecting a huge amount for 1 mark. Right, now on part C, pretty sure without going on to the next part, but pretty sure it's going to say solve the equations, or it might say work out how much material is needed for each one. Part C, yep, calculate the amount of material to make 1 cloak and 1 dress. Right, I have got the 2 equations. I've scribbled them down. So these were the 2 equations from part A and B. Now again, if you would have done this question slightly different from the way that I'm doing it, pause the video, do your own way, and just come back and check. Okay? Right, the method that I would use to do these is, I want to get the D's up to the same number, except 1 positive and 1 negative, so that when I add them, it cancels out. I'm going to take 3 and 4 up to 12, because 3 and 4 both get into 12. 12 can be divided by 3 and 4. So to take the first one up to 12, I'm going to times it by 4. To take the second one up to 12, remember, it's negative 12 we want to take this one up to. I'm going to multiply the second equation by negative 3. I'm going to write down my two new equations, okay? Full equation at the top times by 4. 8c, 12d, 4 times 9.6. Remember, this is non-calculator. 4 times 9.6, 38.4. Second equation, multiplying by negative 3. Multiplying by negative 3. 13.3 times negative 3 would be negative 39.9. Remember, it's non-calculator. Right, remember the whole point of doing that is so that we've got positive 12, negative 12, we add them up and they cancel out. They always cancel out when you add them up. 8 add negative 9, or negative 9 add 8. We're adding up the C values now here on the left. Negative 9 add 8 adds up to negative 1C. The D's have cancelled out, that was the whole point. Now we're going to add up these two. Negative 39.9 add 38.4, or the difference between them would be negative 1.5. So we've got negative C is negative 1.5, therefore C is just 1.5. Now remember what C actually means. C is the amount of material to make a cloak. So a cloak would be 1.5 what? I don't know, is it square metres? 1.5 square metres. Right, is this question finished? No, it's not, because remember simultaneous equations has two unknown values. We now need to go back and find out what the value of D is. Okay, I'm going to rub that wee sum out and I'm going to show us how to go back and find the value of D. To find the value of D, we sub in the value of C. So we already know that C is 1.5, we've just worked it out. Take one of your original equations. I'll take the first one. There's the original equation. Now that I know it's C is 1.5, I'm going to sub it in. Now remember, 2C means 2 times 1.5. We're subbing in the fact that we know that C is 1.5. Okay, 2 times 1.5 is 3. So 3 add 3D is 9.6. I'm going to move the 3 onto the right hand side. So 3D is actually equal to 9.6 take away 3. 3D would equal 6.6 then. And remember, how do you find D? 6.6 divided by 3, 2.2. So D is 2.2, but remember, what does D actually stand for? It's how much material is used for a dress. Okay? Please make sure you finish your answers by stating clearly, using words, not C equals and D equals. Right, number 5. Pretty sure we've done one like this recently again. The cattle farmer records the weight of some of the calves. Find the equation of that line of best fit, the dotted line, or the line that's been put on the dots there, right? So we need to know coordinates. It says find the equation of the line. Now, as soon as it's mentioned equation of line, the first thing you really should be thinking is y equals mx plus c. Do remember, it says in terms of a and w, we'll change them at the end. A is on the x-axis, W is on the y-axis, okay? So instead of x and y in our equation, we'll change them to A and W, but we'll do that at the end. Right, we need to find equation of the line. M is the gradient, remember? To get the gradient, we need coordinates, and we're using the gradient formula, which is y2 minus y1 over x2 minus x1. Again, not on the formula list, okay? The gradient formula then. Where's the coordinates? Right, point D is a 3-month-old calf which weighs 100. 3 months, right, ages in months, the first numbers in months, so the first coordinate is 3, and the weight is on the y-axis, so it's 3/100. That's our coordinate of the first point. Point D, it told us point D is 15-month-old calf, and it weighs 340. So that's our coordinates that we are going to use in this gradient formula. The number 3 I'll call x1 and y1, and the second coordinate I'll call it x2 and y2. So let's sub them in. 340 take away 100 at the top over 15, take away 3. 240 over 12. Those numbers are pretty straightforward to deal with. Remember, it's non-calculator. I know that 24 divided by 12 is 2, so it's 20. That is our gradient. That's our m value for our equation of a line. Okay, so I'm just going to come up here. The equation of a line, remember, is y equals mx plus c. We know that m is 20, so it's y equals 20x plus c. We can't leave it like that. We have to find c. C is the y-intercept. I can't read off the y-intercept, right? Okay, if it was very obvious in the picture, we could just read off the y-intercept, but it isn't. Right, to do this, we need to use one of our coordinates. I'm going to use the point 3, 100. That's our x, and that's our y. And we'll basically sub them in, x and y. Okay, so the y is 100. I'll sub it into this equation. Y is 100. 20x means 20 times x. X was 3. So really what this equation says, 100 is equal to 60 add c. Now if 60 add c is equal to 100, we should be able to see the numbers are straightforward. 100 take away 60, c is actually 40 then. So the equation, what is the equation of the line? Instead of y equals mx plus c, remember, put the numbers in the correct position. Not only the m and the c, which is 20 and 40, it's a and w. A is on the x-axis, w is on the y-axis. So it's w equals, the gradient's 20. The x value is a letter a, okay, plus the c value is 40. So that is our answer there. Okay, that is the equation of this line. That's part A. Part B. Use your equation from part A. That's the equation. Use your equation from part A to find the weight of a 1-year-old calf. Right, let's just check. It was either the W or the A that stood, that represented the age. Let's go back and just double check. It said here at the very, very top, the age is represented by the letter A, but it's in months. Okay, it was talking about a 3-month and a 15-month-old questions. Right, let's see. So A is the age, but it's in months. So are we putting in A as 1 then? No, it's a 1-year-old. So the age is actually 12 months. Okay, we're not putting in A as 1 because A is in months. So it's 20 times 12 because the age is a 12-month-old. 12-month-old. Right, here we are. 20 times 12. 2 times 12 is 24. So 20 times 12 is 240. Plus 40 is 280. 280 what? It's the weight. I think it was in kilograms. The weight was in kilograms. Okay. And this will be the last one. Number 6, determine the nature of the roots. Right. Nature of the roots. I'm hoping that you're thinking nature of the roots. Hopefully you're thinking the right thing. Yep. B squared minus 4ac. This is the part of the quadratic formula that helps us determine the nature of the roots. A, B and C. A is 7. A is the number of x squareds. B is 5. And C is negative 1. We're now going to sub them into the formula. 5 squared, take away. 4ac means 4 times A times C. 5 squared, 25. 4 times 7 times minus 1. 4 times 7 is 28 times negative 1. So it's negative 28, that part. What happens when you do 25 take away a negative 28? You actually do 25 plus 28. So it's 53. Okay. Now the question says determine the nature of the roots. The nature of the roots is determined by this value. It's very important that you write this statement correct. We don't just say, and I think some of you were thinking, oh, real roots, things like that. Yes, you're thinking the correct thing, but we need to write, because b squared minus 4ac is greater than 0. Right? If that number 53 turned out as a negative number, we'd say b squared minus 4ac is less than 0. We always compare it to 0. Then we say there are two real, not red, two real distinct roots. Basically, there's two roots, they're real numbers, and there are two different numbers. Okay, two real and distinct roots. Okay, remember, if it's equal to 0, you say there are equal real roots, or there's two real roots, but they're the same value. If it's less than 0, you say there are no real roots. Okay, now please go and do the questions that I've supplied that go along with this, and then you'll come back and do part 2. Right, good luck. Remember, I'm here for help.